Greetings, people of the internet. Welcome to lesson 6 of our Golang for Absolute Beginners series. Today we are going to be looking at slices, which are basically lists in a bit more detail. I'm going to make a card game which I invented, and to do that we're going to need a means of storing a deck of cards and then shuffling that so we keep track of the order. And that's why we're going to use this slice. I've said array in the list, but it's a slice. And to play this game, each player takes all of the cards of a particular suit and uses only them. So our list only needs to store the number for each card. We don't need to store its suit. And that's that. Before we begin this, how did you do at last week's challenge? Last week I set you a challenge to make an asker that uses the range, that limits people's questions to a certain range, but using the same basic technique. So here was the outline I gave you: ask, range, message, string, low, high. So it would take the lowest and the highest numbers and a message, and I put string here in the wrong case, so we'll fix that first. And so it's lowercase for string, and then we're going to do this loop. Now you may or may not have noticed that we already have a function that asks ints. So we only need to check if the ints that we ask for are correct. So here's our askInt function. It takes a message and returns an int. So we only need to check whether it's in range or not. So let's first start with I : equals askInt, and then we take our message. Now, you could have done this without using the askInt method. You could have used the buffered IO and the scanner. In fact, by doing this, we're going to use the buffered IO and scanner, but it's just done in another function, and we don't have to handle it. If I is if there are two ways of doing this. The way I don't think I've shown you yet: if I is greater than or equal to low, and I is less than or equal to high, return I. Otherwise, we print a message and then we go back to the beginning of the loop and ask for another number. So the message will be funct.printf number not in range %d. So that's the two numbers, and then a new line, and there we can put low and high. So that's a complaint that we've not been given the numbers that we needed, and then it will go back to the beginning. And this should work if this, but I've done something that I haven't told you about. So this using an and here is saying if this is true and this is true. But since I didn't actually require you to, haven't taught you that yet, I'm going to show you how we do it without that. And that would be a var OK : equals true. If I is less than low, OK equals false. This keyboard is slightly larger than the one I'm used to. If I is greater than high, OK equals false. If OK, return I. Basically the same as this. We've done this, does this check, and it fails if it fails on either of these two being not true. And this, we fail on it being not true here, and we fail on it not being not true here, and then we just have a single variable that we're checking it with. So the result of this section here is exactly the same as this. So you could have done it the way that I'm showing you here, but for smaller code right now, I'm just going to get rid of this, and we don't need the OK variable. And let's test it. Well, I think the best place to test this would be in our game that we wrote last week. So we'll go tab edit dash lesson 3 in here. So we had somewhere we had an ask int, and I think we can demand that fits within a range. Let's look for an ask int this way. ASKINT. There's one. So it now says take a guess. But we can actually put 0 and 100 here. Oh, and it's now ask range. So, in theory, is it keeper or seeker first? Seeker first. Let's get rid of seeker. My main cd script cd dash lesson 3 go run lesson 3. I'm thinking of a number. Take a guess. If I say 1000, it says it's not in the range 0 to 100, so it's just said it hasn't even considered that a guess. Whereas if I say 80, if I say a word, it complains this is not a number. And if I say 45, then it's happy, then its answer is higher. So that has actually worked, which is nice. Let's carry on to our array thing then, shall we? Let's quit this program. I don't actually need it to finish. And I'll quit this. And here we're going to make a new project. So I'm going to do make directory, and this will be lesson 6. No, this will be, what should we call it? Candlestick. This is the name of my game. It's unique candlestick. So candlestick. And then in there, vim edit, tab edit, candlestick, and we'll call it candlestick.go. Okay, so package main as usual, and we did a func main. That was wrong. Main open bracket. Of course, there's a squiggly braces just like usual, and here's where all the majority of our code goes. And the first thing we're going to try and do is we're going to create a list of cards, and that is going to be our slice. Okay, and to create a slice, it looks a bit like that. So cards equals, and this will be of int, so it's a slice of ints. So that's a list of ints, and currently it doesn't exist, and this should be a colon equals, and when you declare a new array you use the word make, or when you declare a new slice, and we can set its length here. And actually we might as well, because I know we're going to put 13 cards in here. So if we keep, whenever a slice needs to grow beyond its actual capacity, it's going to grab new memory, and we don't want it to do that. Well, every time it does that, it takes more work, so we might as well set it to the size it needs to be. Actually, we could use a proper array here, but I'm not going to. Cards. And now we've got a for loop. For I colon equals 0. I is less than 13. That's the number of cards we're going to add, right? I plus plus. And inside this loop here, cards at position I equals, and actually we're going to put I plus 1 because we're going to use 1 for ace and 13 for king. So I plus 1. And just to finish this, I'm going to put funct.print line. I think we can get away with this actually. Let's see if it works. I think this should work. What I'm actually doing here, because I'm actually setting them, is I've actually fixed the length here. This may have a complaint, it may not. Let's give it a go. So we need to move to the right place. CD dash CD candlestick. And here, go run candlestick.go. Undefined funct. Of course. Let's import funct. Import funct. Go run candlestick.go. And so we have our array of the numbers from 1 to 13. That actually wasn't too tricky, so let's have a quick look again at the code that we've written. Cards, equals make a slice. Actually, no, I keep saying array, I mean slice. Make a slice of ints and give it a length of 13. And then we set I to 0 and check that I is less than 13. And then cards at 0 equals 0 plus 1. I becomes I plus 1. It was 0, now it's 1. We check that that's less than 13. Cards at 1 equals 1 plus 1 is 2, and that's how we've completed our list of cards. And when you see the printed values out here, that is what we're expecting. So now we need to shuffle them. For I equals 0 semicolon I is less than length. No, we're just going to work with the whole deck right now. Cards. I is less than. We're going to use 13 because we know what that number is, but at some point we might want to use a variable for that. And here's our shuffle. We're going to need to use rand, aren't we? Now, we used rand before. I'm pretty sure it's just rand. It might be math. I think it's math rand. Either way, here we can go math. Here we can go Golang lets you get away with this, but I'm actually going to do it the slow way. We want to swap the values of two variables in an array, but the problem is if we copy the value from the one place to the next, then we try and copy the other one back. It's too late because we've already overwritten it. So we need to have a third variable, a place where we can put it before it gets squished by the other value. So what we're going to be doing is we're just going to randomly swap every number in this array with another one. So every card should, in theory, get swapped once or at least twice. They all get swapped at least once, but they might get swapped twice, maybe 3 times. So it's new location, new lock, equals rand.int 0, 30. I think we just put 13 actually. So that should get us a value from I think that gets us a value less than 13. Was it inclusive? No, it wasn't inclusive. That would be why it complained with 0 last time. New lock. So now we've got a new location that we're going to move them to. And then we do swapper colon equals cards at I. So our swapper is our new swapping variable. So that's where we take the value that's in there, and then we put cards at I equals cards at new lock. And you want to say cards at new lock equals cards at I. Oh, there's the equals. But the problem with that is, of course, cards at I has now got the new value in, so we can't use that, and that's why we created our swapper variable. And this will now should shuffle all the cards so that they are in a different place. It will shuffle them every time exactly the same because we haven't seeded the random variable. That was something I was supposed to do. Was find out how to get time in real time. So give me a second. I'm just going to quickly look up how to get time as an integer. Golang time as int 64. So time.now equals time.now, and then we get seconds. Now.unix. So that was all I needed. Time.now.unix ought to do the job to seed it. So in theory, if we do something like this, rand.seed, capital S, seed time.now.unix, and I obviously need to import time, which was I think it's just time. Let's try it. Time. So that's shuffled it differently and differently again. Brilliant. So this is actually working, and that's what we like to see. So we now have a working, completely randomized deck of cards. It seems to be mostly random. One seems to still be at the front quite often, so it's maybe not as random as I'd like, but one does get shuffled. We can always just run the shuffle mechanism a second or third time just to guarantee that we get different values, but it seems to be everything's going to different places. If you do it quickly, you might get the same value because it's actually on seconds, but I think that's okay. So we now have a shuffled deck of cards in a list. That's going to be a good place to start. What I'm going to do first I want you guys, for your challenge, is I want you to pull this out and make it into a separate function that will create a new deck of cards. I want it to create 4 decks of cards. Now, if you're feeling really up for it, what would be really good, I want to make these challenges get a bit harder from time to time. So this will mean you have to think a little bit. I want you to have a function, a separate function that makes a new deck of cards and shuffles them like this, which you can already use the functions I've already put in. But the thing I want you to do after that is I want you to have 4 arrays of cards. Of slices of cards. Then you can... It'll take a little bit of thinking about how you actually make it, but you can make the function so that it returns your slice of cards. So I'm not going to tell you the answer to this. A little bit of research on golang.org should help. But yeah, if you're feeling up for a bit of a challenge, do a little bit of research and see if you can make it so that it returns, so that you can create 4 separate arrays, each player with different cards. We're going to have a 4-player game and everyone is going to have their own separate list of cards. Hopefully that's clear. And I'll see you next week. Don't forget to like and subscribe.